Hi, welcome back. Good to see you again. How's trigonometry going? Are we working out all those sides? Can you see the practical application of this? In those last two or three problems from Pearson's, you can see this could be very useful stuff. Well, we said that trigonometry was about triangle measurement, and of course now we want to find angles. Because what if we wanted to find the angle at which we had to fire a rocket to get over an obstacle? We might want to know what is that angle if we are 500 metres away from a 20-metre high cliff. What angle do we have to fire at? That sort of thing. How can we find angles now? Is it possible, do you think? Well, it should be, because every angle, remember this, every angle has its characteristic or special, unique, has its characteristic ratios in a 90-degree triangle, in a right-angled triangle. So if we get a ratio, can we go backwards and trace what the angle was? So Pearson's up here said, well, if each one's got trig ratios which are unique to that angle, then if it comes up to the sine of theta is 0.72, can we backtrack? What would theta be? Let's do my example here. I like mine better. And so what is theta here? What is that angle that we have to fire our rocket at to get over the 20-metre high cliff, which is 500 metres away? All right, let's go and do some trigonometry. So we're going to write down SOHCAHTOA again. And this time we see that we don't know the angle, theta, but look at that. That's the opposite. So the opposite is 20. We did this before. And then go to the right angle. That's the hypotenuse. Haven't got that. So the other one that's left is the adjacent. So we're working with the opposite and the adjacent here. So let's go along. Well, there it is. Opposite and adjacent. So it's the same method as before. Identify what the sides are in the triangle, put the information down, choose a ratio. So this will be tan of theta equals opposite over adjacent, like that. And so the tan of theta, we could work that out. And if you work that out on your calculator, it's 0.04. Oh, so we have the characteristic unique ratio of 0.04. Can we backtrack and find what theta is? So backtracking is given the symbol tan -1. We read this as the inverse tan. So we want the angle whose tangent is 0.04. Going backwards there. Let's go to the calculator over here, and here we are. Here are the tan buttons and stuff down here. Can you see? Here's the tan button, and just up there is the button tan -1. So on the calculator, let's just come down here a bit. On the calculator, we've got to go shift, because we want the second function up the top here in yellow, shift tan, and that gives us tan -1, and then enter 0.04, and we come up with the angle. So I want you to actually do that on your calculator and see what you get. You pause the presentation now. So what did you get? For that one then, theta is equal to, what do you think? I think it comes to 2.29 degrees. It's not a very big angle, because we've got a long distance to get over the hill. So can you do that, do you think? Same approach, this time theta is missing. You have its characteristic ratio, and you actually have to go backwards using the calculator to find the angle with that ratio. All right, so have a look at your calculator. You need to be in run mode and functioning there. So have a go at checking that one. Let's go down now. Have a look at some of Pearson's examples. So here are our steps again. Label the sides of a triangle. So here's our problem. Can we find theta in there? So we're going to label the sides, go into the angle, that's opposite, that's the hypotenuse, other side is the adjacent. Decide the trig ratio. Well, we generally write things down. They've left a step out there. We generally write down theta, the opposite is 21, hypotenuse is 50. I'd write those down, then choose that we've got opposite over hypotenuse, which in SOHCAHTOA means you've got sine. So you put down the sine of theta. This time you've got the numbers to find it. So now you want to come reverse. You want to find the angle whose sine is that. You're coming backwards from the characteristic value to the angle. So you could do that. You don't have to work out 21 over 50 separately. If you use a bracket on the calculator, put shift sine, and that gives you sine neg 1, and then just bracket it and do it all as one step on the calculator. You get this many degrees. And if you want it in degrees and minutes, just remember 0.834 degrees. To get the number of minutes there, you'll multiply by 60 because there's 60 minutes in a degree. Okay, or 1 minute is a 60th of a degree. So if you do that for the decimal part, you find it's to the nearest minute 50 degrees. We won't bother with minutes and seconds like Pearson's does. Let's go on now and look at another one. Here's another example. I've blown this one up a bit. So here's our problem. A 1 metre ladder is leaning against the wall. It reaches a height of 1.2 metres. So there it is there. Draw a diagram and find the angle that the top of the ladder makes with the wall. So we're trying to find that angle. And the ladder is 1.8 metres long and it reaches 1.2 up the wall. Go through the same thing. Here they've done it better this time. First of all, show the sides. Look at the angle, that's the opposite. Go to the hypotenuse, go to the 90, that's the hypotenuse. So what's left is the adjacent. List down what you've got. Theta is a question mark, that's what you're trying to find. This time, the adjacent is 1.2 and the hypotenuse is 1.8. Using SOHCAHTOA, pick out which ratio you're going to use. You've got the adjacent and the hypotenuse, so it's cosine. So you can write that down, put the numbers in. Adjacent is 1.2, hypotenuse 1.8. Excuse me, so that's the ratio, and you want to find the angle. So it's shift cos button to get cos neg 1. It means you're going to come back from a cosine value, a ratio that's known, to find the characteristic angle. Let's just go back up there. Okay, so what do you get? You get this in decimal degrees, and you can round it off to the nearest degree because that's what they asked this time. And you should state your answer. State your answer, not in the jargon or the symbols of the question, but in the answering contextually what the question asked, and that was what is the angle that makes with the wall correct to the nearest degree. So here the ladder makes an angle of approximately 48 degrees with the wall. So it is very, very important that you stick to the protocol. What is it again? Draw a diagram, label the sides with the lengths and whether they're opposite or hypotenuse, decide on the trig ratio, substitute the values. This time use the inverse of the ratio to backtrack to find theta. Because this time we are trying to find the angle whose ratio is that particular value that we've calculated. Remember, every angle has its characteristic or fingerprint set of 3 ratios which will be produced when that angle finds itself in a right angle triangle. So these angles can't escape us. We can find what they are, no matter where they hide in that right angle triangle. All right, let's go down and have a look at some problems. So these are all like the examples, or the one that I did first. So that's what Pearson's have got here, reference to the worked example. So you can go back and do that. In this first problem, we are not going to do this second part, in degrees, minutes and seconds. Going to leave that out. That's not what we need to do in the Australian context, so we're only going to round it to 2 decimal places. So here are the answers here. We will leave those out for the moment. Okay, so I want you to freeze the presentation, have a look. The answers this time I put right next to them over here, so you can check as you go. Don't do a lot of problems and find they're all wrong. Okay, so coming down here, we'll just bring on the other few here, 3, 4, 5 and 6. So have a go there. You have to draw a diagram, got to get that diagram right to be sure. So I'll just toggle back so you can mark those, 3, 4, 5 and 6. Just toggle around so you can easily get the answers there. Freezing it at various points. Okay, so then we want to go down to 7, 8. We'll see if we can get 9 on. Just 7, 8 there. And at any stage you can pause it so that you can draw your diagram. And then straight away, really, after that, we need to just check the answers back up here. 7, 8. Okay. I'll freeze it there. Let's keep going. Here we have 9, 10 and 11. Let's leave it at those 3 there. Pause those. Plenty of exercises to practice with there. And did you get them right? Okay. 9, 10, 11 there. Okay. Then we'll go on and having a look at the open-ended 2 questions there. There are multiple answers to this because that's what open-ended means. There isn't a definite answer. Depending upon how you construct the problem, you will get a correct solution in the way in which you have set the problem up. So you need to get a teacher to have a look at what you've done there. In Pearson's there, they will give a typical solution, but you may well get another one which is consistent and correct. So let's look at 12 and 13 now, the solutions of those. These are therefore sample answers, because you can actually make assumptions here. Being open-ended means not all the variables are specified. You could use other values and discuss what happens for that range of values. All right, well, I'll leave you with those problems now, and you can, of course, rewind the presentation to check these worked examples. I haven't put worked example 8. I've done my own up there. Work example 9 and 10 are part of the presentation. All right, I hope you're getting excited about how trigonometry can actually be useful to you in everyday life, and some interesting questions you can answer. So there's more coming up, so I want you to build your skills, have some fun with this, and I'll catch you in the next presentation. For now, it's cheers from me.